The root word of rational is ratio. And basically what it is an algebraic expression on top of another algebraic expression. So what that means is it has an x, a big fraction with an x in it. So something like x squared is just an example of one. So example one would look like this right here, where you have an algebraic expression on top and an algebraic expression on the bottom. What we're going to go through is how to simplify these and add and subtract and multiply and divide these. And again, you can see this is set up like a factoring problem. That's why we will still use our factoring steps here. The very first thing though is on any number, on any fraction, what number can I not have in the bottom? 0. I can't take any number divided by 0 is undefined. It does not work. Cannot divide by 0. So the first thing we're going to talk about is domain. And way back when we talked about domain, we talked about the set of numbers. And the domain was your first number and your range was your second number. But the domain deals with your x's. So the domain deals with your x's. So when it asks you to find the domain of a problem, it's talking about find every single x number that would work in this problem. So if I think about plugging in numbers, whether it would work or not. Well, if you think about plugging in numbers, there's a whole bunch of different numbers you can plug in. So what you want to do is figure out what x cannot be, and then say, okay, x could be everything besides that. So the way you figure out what x cannot be is you just look at the denominator. This right here cannot equal 0. So what number would I plug in right here to make that equal 0? 3. If I put a 3 right there, it'd be 3 minus 3, it'd be 0. So on this problem, the domain is every other number besides x cannot equal 3. Every other number besides x cannot equal 3. Which they write that. Everybody writes this a different way, so let me look and see. I don't think it's right the hard way, though. Okay. Yeah, right here, x is any number such that x is a real number and x cannot equal that number. So x is any number, but x cannot equal that number. So what you did there, the way you actually find it, this one we can just kind of look at and tell, but the easy way to do that, if it gets a little tougher, is just set the denominator equal to 0 and solve it. So if I set that equal to 0 and solve it, add 3 to both sides, you get x equals 3. That's the one number it can't be. So if it's harder, what you do to find the domain is you set the denominator equal to 0. All right, so like on this one, what number can I not have in the denominator here? 0, right? 2 times 0 would be 0. So the only number I can't have in there is t cannot equal 0. What about that one? Right, 9 minus what number would be x, or 9 minus what number would give you 0? So what was that, 6x over 9 minus x? So 9 minus what number would give you 0? Again, if it looks tricky, just set it equal to 0 and solve that. So I subtract 9 from both sides. I get negative x equals negative 9, divided by negative 1. So x can be any number besides 9. So you set the denominator equal to 0 and figure out what number x cannot be. What about this one? Is there any number x cannot be? Yeah, there's not an x on the bottom, so it doesn't matter what I plug into the top because that'll never mess it up. If I get 0 on the bottom, that's what messes it up. So this could be any number. It could be any real number. Because there's not an x on the bottom. Let's plug that in. Did that one, did that one. All right, so what about one like this where you have x cubed plus 8x squared minus 9x?
Do the first factor and then the factor at the top and right, and then you get the 2 numbers in parentheses, so you get 2 and 2.
Right. So what you got to do here is you're just setting the denominator equal to 0. Well, this one, if I look at it, what you just start doing is going through the factoring steps. The first thing was pull out your GCF, which is an x. Should be x squared plus 8x minus 9. So now you're looking at inside the middle, what multiplies to be negative 9 and 8. Adds up to be 8. Multiplies from negative 9, adds up to be 8.
Negative 1,
-1, +9, right? So x times x is x squared, 9 times -1 is -9, 9 minus 1 is +8. So you have 3 different answers on this one. Remember, you set each of those equal to 0, so x equals 0, x plus 9 equals 0, and x minus 1 equals 0. So your 3 answers are 0, subtract 9, would be -9, add 1, would be +1. So again, that's the 3 numbers that x cannot be. If I plug those in, this would add up to be 0 on the bottom. So x could be any other number besides 0, -9, or 1.
So you don't solve the numerator.
Nope, all we got to do is look at the denominator, because we can't have 0 on the bottom. What's that one factor down to be?
x minus 3.
X minus 3 and x plus 3. So you have 2 answers, positive and -3. All right, so now we're getting into the simplifying part, which the multiplying and dividing are just big simplifying problems, so we'll spend a little bit of time on this. When you have a fraction, these are just big fractions with x's on top and the bottom. So I'm going to do how you do fractions on each problem, how we do it, because if you ever forget, just remember what you do on a fraction. If you have a fraction, let's say 10/15, and I'm reducing this down. Well, what did you do there? The way we think about it is we divide the top and the bottom by 5 and you get 2/3, right? Now the reason that works, because if I did the factor tree for 10, it'd be what? 2 times 5 is 10 and 3 times 5 is 15. So what happens here is I simplify the top and I simplify the bottom, and then I can just cancel out the 5s and get 2/3. That's why we divide by 5, because they share 5. So that's kind of how we're going to simplify. We're going to break down the top and we're going to break down the bottom, and then cancel out anything that's the same. Before we do that, though, that's the next question asks. Equivalence. I think we did this like the very first night. If I have -2/3, there's a couple different ways I can write that, and it mean the same exact thing. So this is the correct way to write it. The whole fraction is negative, but I could also do -2 divided by 3. Still the same number, because -2 divided by 3 is negative, and negative divided by positive is a negative, so it's still -2/3. So that means the same thing. Or the way you never write it though is +2 divided by -3, because a positive divided by a negative is still a negative. Okay, so these all mean the same thing. It's just moving the negative in a different spot. So this question right here, -x. This question right here says to write it in 4 equivalent different ways. So here I have negative fraction. So just like we did up here in the 2/3, I can do negative of the top and keep the bottom just like it is. Or I could keep the top like it is and do a negative of the bottom. Okay, so these all mean the same thing, because I have negative divided by positive is a negative, or positive divided by negative is a negative. The other way, because you got to come up with 4, is to just go ahead and distribute that negative. If I distribute that negative, it'd be -x plus 11 over x plus 2. And then this one, if I distribute the negative on the bottom, it'd be -x minus 2. So that gives me actually 4 different ways to write this one problem, just because of the way the signs work. The point of that is when we go to simplify, we're going to look for similar things, so we can kind of manipulate it by the signs and not change the problem. It'll all be written the same way. Oh, let's do this one. 5x minus 10, x squared minus 2x. All right, so here is your simplifying problem. So look at the top. What can I just the top? What can I do on the top? You factor out a 5, so you get x minus 2. On the bottom, what can you do? Factor out an x, so you get x minus 2. So we're going to simplify the top, we're going to simplify the bottom, and then when we look, something should cancel out, and then we just end up with 5 over x. Why does that cancel out?
Yeah.
They're the same. Just like when I had that fraction a second ago, and I had 10 over 15. We broke it down to 2 times 5 and 3 times 5.
Oh,
The 5s are the same, so they just cancel out, and you get 2/3.
okay. Okay.
Kind of that same idea.
Oh, okay.
X plus. Let me check my summary real quick. Minus 2x minus 6. All right, so on this one, when you're simplifying this, on the top, x plus 7, I can't do anything there. That doesn't break down at all. There's nothing to pull out or anything. But on the bottom, I'm looking at, okay, the first thing when I see x squared and x, I'm thinking factor, right? So what multiplies to be negative 63 and adds up to be negative 2? Negative 9 and positive 7. So I end up with x plus 7 and x minus 9. So now I have an x plus 7 on top and an x plus 7 on the bottom, so they cancel out. And there's nothing left on top, so it's just 1 over x minus 9. Yeah, let's go fraction like that. 2x squared plus 5x plus 3. All right, so I'm kind of going back over all the factoring so that we have it and can use it in the next section. So here on this one on the top, I don't have any GCF, but I have an x squared and an x. So if I do 2 times 3, I'm going to do, okay, so it multiplies to be 6 and adds up to be 5. Multiplies to be 6 and adds up to be 5. Just be 2 and 3, wouldn't it? Yeah, 2 times 3 is 6, 2 plus 3 is 5. So then I come over here and I write 2x in both spots. You're doing my y plus 3 and plus 2. And then I can divide this one by 2. So I end up with 2x plus 3 on top and x plus 1 on the bottom. I'm sorry, x plus 1. I do have x plus 1 on the bottom too. So now the x plus 1s cancel out, so I end up with just 2x plus 3. So just reminding you about all the different factoring that we have. I think there's one more I need to remind you of. Yeah, thanks. All right, do you remember this factoring? Not like a cube, but you're thinking. Right, a times b, a squared and b squared, a and b, same sign, opposite sign, always plus. So my a is x, and y'all were saying b was 4, y'all were getting that. So you have a and b, a squared and b squared, a times b, same sign, opposite sign, plus sign. So then that cancels out, and I just get left with x squared minus 4x plus 16. All right, so if you get one like this, I believe this was back before I skipped it. The first thing I would do is rearrange that bottom one, so it'd be negative x plus 8. Well, now can I make this be the same somehow? It looks really close. Where? In the bottom, yeah. If I pull out -1 in the bottom, that becomes positive x, and that would become negative 8. Well, now I have x minus 8 on top and x minus 8 on the bottom. So that's just like 1 divided by -1 would be -1.
That was the original problem.
This right here? Right, so the first thing all I did was rearrange and put the x first so I could look at it. Make it negative x and positive 8, just rearrange those. Then you pull out a -1 to make it the same. One other thing I should say too, he just made me think of, how many terms are in this problem right here? 3. Okay, there's 3 terms in here. How many have an x in it? 2. So I cannot just say that's my answer, because all three terms would have to have that same number to be able to pull it out. Okay? So this is x divided by x and 2 divided by x. So I can't just pull that out and cross it out. All 3 terms have to share something in common. Or if you have something like this, what? This, no, that's as simplified as that gets. You just leave it like that. Or something like this. This one has 4 terms in it. Okay, so it looks like I could do, okay, x divided by x is 1, 2 plus 4 plus 2 is 2, and I just get 3. Okay, you can't do that because all 4 terms would have to share something. I can't just have these 2 share something and these 2 share something. There's 4 different terms there, so they all would need to share a number. They'll just divide it. All right, on to 7.2.